Okay, so we're going to talk about section 5.2, okay? And specifically, we talked about some properties, and I'm going to add some more, okay? These are properties of radicals, I'll just say. Okay, we're going to talk about two things. The first thing is I'm going to add two more properties to your little tool bag that we discussed the previous day, all right? The next one, the property that we're going to talk about first is called the product property. Okay, and what this says is that if you have something under an nth root, okay, you can separate them. Okay, so you can write it as nth root A times the nth root of B. Okay. And the second property that I'm going to share with you really quick is called the quotient property. I think you guys have already been using these in your homework. They're kind of like the inverse of some of the properties that we talked about in class. Okay, so the quotient property likewise says if you have the nth root of A over B, you can write them as separate radicals. So you can write that as the nth root of A over nth root of B. Okay. So I just wanted to list those out for you really quickly because you don't have those in your toolkit so far. Today though, however, for the video, I want to talk about how to simplify radicals, okay, or write them in simple form. Okay, and I'll write simple form, okay. And I'm going to talk about them in two ways. The first one is we're going to simplify a radical if you have a square root on the bottom. And I'll write square root in denominator. Okay, and then the second one is that if you have a square root in the denominator, but it's also in the form of a conjugate, okay? Okay. So what do I mean by that? So I'm going to give you two examples. One where you just have to take out, I won't even say square root, okay? Because it may be a third root or fourth root. The first case I'm going to talk about is if you have a root in the denominator, and then if you have a root that's in the form of a conjugate, okay? So let's go ahead and just talk about these two examples here. So I made a mention a while ago in class that when you simplify a radical, we were able to get it to a point, but there was a point where we were doing a problem and we had a square root on the denominator. And I said, well, you know, it's totally simplified except the fact that we have a square root or a root in the bottom, okay? And typically in mathematics, we don't like to leave it that way. It's just kind of unfashionable, okay? And so let me give you an example. If we had a problem like x squared over third root of y to the 13. Okay, there may not be any additional properties that we have learned so far that can clean this up. So we've gotten it to this point, okay? And at this point, we probably will leave the answer except for the fact that, as I mentioned, it's kind of unfashionable in mathematics to have a root in the denominator. So the question is, how do you get rid of that root in the denominator? It kind of becomes kind of a manipulation where you have to just multiply this whole thing by 1, okay? And what I mean by that, okay, is that you have to figure out what you can multiply to the top and the bottom, or sorry, multiply the bottom so that you can get it to something nice and neat, okay? So I'm going to stop here for a second. We have a third root here. And if I write, and I'll write this to the side, if I write just the denominator right here, if I move the third root into a rational form, we would have y is equal to 13 over 3, which is not really nice because this is not an evenly divisible fraction. Okay, so if we were to do it on a calculator, it would be, you know, like 4 point something. All right, so the question is, what can I change this to right here? Okay, so that it becomes something that's easily divisible by 3, okay? And so I think the easiest thing is if we add 2 and make it 15, that would be ideal because 15 is divisible by 3, all right? So the question is, what can I multiply this bottom by to get 15? Well, if I use the properties, I know that if I add 2 more to this 13, I can get 15. So essentially, I'm not changing the original if I multiply the bottom by the same thing on the top, because I'm doing it legally, because this essentially is just equal to 1, right? Root 3y squared over root 3y squared is just 1. So if I'm multiplying something by 1, I'm not changing the original form. I'm just basically multiplying by its identity, all right? But the thing that's a little bit manipulative here is because this 1 doesn't obviously look like a 1, I've created this rational expression with radicals in it because my goal is to try to manipulate it to look like something that I want, okay? So if I take the third root of y13 times the third root of y squared, I end up with third root of y15. And then on the top, I have x squared times the third root of y squared. All right? So at this point, this is our goal, was to try to get this to be 15, because I can rewrite this as x squared, third root of y squared, over y to the 15 over 3, which is the same as x squared, third root of y squared, over y to the 5th, okay? And then there's nothing else, unfortunately, that we can do. Now, some of you might be thinking, this looks bigger than this, okay? And I agree. It's not necessarily going to be prettier than the original, but at least it's taking care of the unfashionable, unsightly thing of having that root on the bottom, all right? And so that's how you would get rid of a root on the bottom, is trying to figure out what you can multiply the bottom and the top by that are, that's equal to 1, so it's a ratio that's equal to 1, to clean up the stuff on the bottom, all right? So the second example that I mentioned is if you have a conjugate, okay? So let me go ahead and erase this right here and give you this example of the conjugate. So this, in this case, had just a root, but what if it's attached to something by plus or minus, okay? So in this case, we have 3 over 6 minus root 2, okay? So it would be great if we can multiply something on the top and the bottom like we did here, down here, but this minus sign actually complicates things. So in order to get rid of something that looks like this, we have to multiply it by the conjugate, okay? So 6 minus root 2, the conjugate of that is 6 plus root 2. So when I do the bottom, I'm going to do the top to maintain the fact that I'm only multiplying by 1, okay? I'm not altering it in any illegal way, all right? So when we do that, we end up getting 3 times 6 plus root 2 over, okay? And we're going to multiply this out. And it becomes just basically, if you look at this kind of carefully, a FOIL problem. So 6 times 6, if I distribute it over, gives me 36. Okay? And then I have negative 6 root 2 and positive 6 root 2. Okay? So if I distribute these two, they cancel out each other. And then I have negative root 2 times positive root 2, which is negative root 4, which is, negative root 2, and that's going to be minus 2. All right? Because negative root 2 is like 1.4 something, and if I multiply that by positive root 2, it's like 1.4 something, we get 2. And so the signs make it opposite. So our final answer is going to be, you can multiply the top part out, 18 plus 3 root 2 over 34. And then at this point, we can't factor anything out. Nothing is going to be divisible that we can factor out that is going to be divisible to 34. And so this is the simple form given the conjugate. All right.